All right, so let's take a look at section 1.2. First thing they do in section 1.2 is they give you kind of an outline for how to solve problems. Whether or not you want to write this down, if it's helpful for you, that's up to you. But it's just kind of a general outline about approaching word problems. All right, so first thing I recommend is read the problem, write down anything that you're given, and anything you need to find. Okay? It's always the first thing. Try to figure out, what are they telling me? And what are they asking me to find? Sometimes when you have to find something, picking a variable is a good idea. Okay, so you might have to assign variables at this point, sometimes more than one. Okay, and then we have to devise some kind of plan to solve the problem. Okay, sometimes drawing a picture, that's helpful. When we get to trig, we'll do tons of pictures of triangles and labeling angles and sides. So visualizing it is helpful that way. Making a list. Sometimes a list is helpful. Like if you had a problem that said, here are the letters A, B, C. Tell me all the different ways that I could arrange this, A, B, and C. CBA, ACB, CBA, everything, all the combinations. But lists can kind of take a while, especially if you have a large number of possibilities. Making a list might not be the most efficient way. Setting up an equation is what we'll do a lot of the times. And along with solving or setting up an equation, we'll often plug that into a calculator and graph it. So setting up an equation / graphing an equation. And page 13, they have a bunch more different suggestions for how to solve problems. Okay, but we'll try a couple of these today. Right, so after you've read it, you've kind of figured out what they've given you, what you need to find. Last thing is to go ahead and carry out whatever plan you're going to do. Okay. As I said, sometimes that'll involve using technology, like a calculator, specific graphing calculator. Sometimes just basic algebra, okay, doing it by hand. Nice. Just look at this example. It's about a car rental. It says a company charges $15 to rent a car, and then they charge 20 cents per mile. Right, so I want to set up an equation that basically if somebody said, you know what, I'm going to rent the car I'm going to use it for 200 miles. I want a formula that would give me the total price to rent the car. What do you think the first thing I'd probably have to do is, before I can even start to set up an equation, these things are going to be in the equation. So will the $15 and the 20 cents. But there's going to be some other things in the equation too, and I got to pick them.
You got to make variables.
Yeah, how many variables do you think I'm going to need here?
Just one. With the amount of miles.
One for the amount of miles, and what is that going to calculate?
It's going to use it 20 cents per mile.
All right, so we need a variable for miles, but I think we need a variable for something else too. Yeah.
The total cost.
The total cost. Both of those things are going to be changing in this problem. Okay? So if we're going to graph it, it might make sense to use X and Y. Otherwise, you could use M for miles and C for cost, but generally graphing X and Y makes the most sense. And back from algebra, we know that X is our independent variable. Okay, Y is our dependent variable. So which one should be which here? Let's start with Y. Should that be cost or should that be miles? Yeah, Maddie.
The cost.
Y should be, yeah, right. Y is the cost. Okay, if you read that, the way you'd say it is the cost depends on, or the cost is dependent on miles. Not the other way around. The cost is dependent, so it's your Y variable. Right, so now we have to make our equation. You would think they could give me an equation that would model the cost to rent this car, preferably with Y by itself. Yeah, Brian?
Y
y equals 15 plus 0.2x.
15 plus 0.2x. Sure. It's perfect. Okay. In that equation, if we were to graph it, which maybe we will in a little bit, how would it look if you drew that? What kind of shape would it be? A circle or, yeah? Yeah, it would be linear. It's a linear equation. What's the 0.2?
Slope.
That's your slope. Yep. And the 15? It's the constant, and when you draw it out, it would be the y-intercept. Yep. Good. Right, so we've done what they wanted. We made our equation. Okay, now we could use the model we just made, and we could find the cost for 50 miles, 100 miles, however many we want. Okay, Derek, how am I going to use this and the 50 miles to find the cost?
You would input 50 as x.
Yeah, you're just going to take 50, plug it in for x. Right, so our cost is 15 plus 0.2 x, or in this case, 0.2 times 50. So 0.2, that's a fifth. So 1/5 of 50 is 10. Well, it would cost $25 to rent the car. Okay, and then for 100 miles, could I just double this? Could I say, well, the cost for 50 miles was 25, so the cost for 100 miles is twice as far?
No,
Yeah.
you just double the price for the miles, but not for the initial cost of the 15.
Right.
So just go to 35.
Yeah, even though it's double the mileage, it's not going to be double the cost because you had this y-intercept. Okay, if the y-intercept was 0, then that would work okay. But the 15 doesn't change. Okay, no matter how many miles you drive, that always stays the same. Right. So for this one, it's 15 plus 0.2 times 100. So we get 15 plus 20, or $35. Any questions on that? Okay, plugging in, that's pretty easy. Sometimes the harder part is coming up with the equation to plug in too. This one was pretty straightforward. Okay, that equation that we came up with, that's the algebraic representation of the problem that we had. It basically takes all the words out of the problem, takes out the context. If you just showed this to somebody on paper, they'd have no idea what it represents. That this is the cost per mile, and that's like an initial fee to rent a car. It's just an algebraic equation. Now, if we were going to graph that, if we're going to sketch it, keeping in mind the context of the problem we had, is there anything we might want to be careful about with x? Think about our problem and think about, could any value make sense for x, or only certain ones? Yeah, huh?
X can't be negative.
Right, you wouldn't want to graph anything where x is negative because that'd be negative mileage. Right? So something like that wouldn't make sense. And when we draw these things on the calculator, we'll want to take that into account. All right? Versus if I just gave this as a question in Algebra 1 and said to draw it, with no context, no problem behind it, they could sketch a line, positive and negative forever. This is going to look more like a ray if we draw it. There'll be some minimum cost, and then from there it'll go up. Okay, but won't be negative on the x-axis. And if you draw it, it shouldn't go negative on the y-axis either. That would represent the car company paying you to rent the car. So common sense, that shouldn't happen either. Okay, so this question's based on what we just did, just looking at it a little different. In this case, they're giving us a total cost for renting the car. We want to figure out how many miles Sarah drove. And we're going to try it two ways. I'm going to show you the algebraic approach, which I think most of you probably already know, and then we're going to do it on the graphing calculator. just to start to practice with it. Okay, how would we do that algebraically? How would we find, keep in mind what we're finding, okay, and try to remember what letter that represented, and keep in mind what's given and what letter that represents. Yeah, Brian?
We could start it out by plugging into the equation that it's 50 equals 15 plus 0.2x.
50 equals, what was it? Oh,
Equals
15?
15 plus 0.2x.
So he took the total cost, which was $50, plugged that in for y, and this time we're trying to find mileage. Mileage was what we assigned to the letter x. Okay, and now we'll solve that, hopefully very quickly. Nick, what's my first step to solve that?
Subtract 15 from both sides.
Good, subtract 15 from both sides. Okay, so I get 35 equals 0.2x. And Madison, my last step?
Divide by 0.2.
Good, divide by 0.2. Okay, so 35 divided by 0.2. That's like dividing by a fifth, so it's really going to multiply 35 times 5. That's going to give us what, is it 175? Yeah. And let's just try to remember what we were finding. So if there's a label we need to put on it, miles. How many miles? Okay, anytime you're doing a word problem, make sure you put the right label. It's money, miles. All right, so that's how you can do it algebraically. And now let's take a look at how we can do it on the calculator. Well, first thing I need to do if I'm going to do it on the calculator, make sure you turn it on. And I need to type in my equation. Y equals, and I'm going to put it in slope-intercept form. So I'm going to write the slope part first and then the intercept. You don't have to, but that's just y equals mx plus b. It's normally how we do it. First thing you want to do is press y equals in the upper left. If you have anything there, just press clear. And type in 0.2, and then the x button is to the right of alpha. 0.2x plus 15. All right, let's just graph that. Let's hit and make sure everyone's in the same kind of window. We'll do zoom 6. What this is going to do is it's going to set a window from negative 10 to 10 on the x-axis and negative 10 to 10 on the y-axis. All right, so what happened?
It's outside the range of the screw.
Yeah, remember this line has a y-intercept at 15. So if our window is only going as high as 10, you're not going to see it. All right, so maybe we should set our window. Now we could try it up at 25, and I think you'll start to see it. But remember how high we have to go in this problem. We're trying to find where the cost was equal to $50. So what I like to do is set my window a little higher. So I have a little bit of extra. I only need to go as high as 50, but why don't we just go to 70? Okay, and some other things I might set here while I'm looking at it. Am I going to drive negative mileage? No. So maybe it makes sense just to set that as low as 0. That's the least you could drive. Okay. On the y-axis, they're never going to be paying me money to rent a car, negative money. So maybe I want to set that minimum at 0. That'll just kind of make it so now I'm only going to be looking at quadrant 1. Quadrants 2, 3, and 4 are now going to be off the screen. Great. Any questions on that? Don't worry about the other settings here. Nothing else you need to worry about. Now let's hit graph. Right, so there's our line going up slowly. Now, how many miles did we just say Sarah has to drive for it to cost $50? 175 miles. What's the highest number of miles we can see on our window right now? 10. Okay, remember x is our mileage, so we're looking at the mileage cost between 0 and 10 miles. We've got to go a lot higher than 10. Now, if you didn't know the answer to this problem, you wouldn't know how high you have to go. Sometimes that's part of figuring out your window. What do you think a good value to set my x max at would be? I don't like to set it right at 175 because then the value I'm looking for is going to be right on the edge of the screen. How much?
200.
Yeah, 200. That's probably going to be perfect. Okay. Now what we can do is if you press trace, x is mileage, y is cost. So we can kind of move along this graph and we can see the cost going up as the mileage goes up. And we can kind of get an estimate. Remember, we're looking for where y hits $50. But the problem is it's showing it to me as a decimal. And I can't really get it exact like this. Okay? I don't know if yours is exactly the same, but I'm a little bit too high. Here I'm a little bit too low. All right, so there's a couple things we can do. Okay, one thing we can do is go back to the graph screen. And we want to know where the cost hits 175. So let's substitute in 175, okay, for y2. Oh, no, I'm sorry, that's what we're finding, 50. Plug in 50. Okay, we're looking for where the cost is going to hit $50. What this is going to do is it's going to put a horizontal line right across the screen for me. Okay, if you remember from Algebra 1, y equals a number is a horizontal line. And I can find exactly where that cost is going to hit that line. Okay, and the way you do it, it's under calc. Okay, if you want to find where two graphs cross each other, press second, and then calc, and you should see this menu. Which option there you think makes the most sense? If you're trying to find where two graphs cross. Intersect. So you can either hit 5 or just scroll down to the 5th option. Now, it says on the screen, it should say first curve. If you had multiple graphs on the screen, you might have all kinds of intersections all over the place. You've got to tell it what two lines you want it to find the intersection for. Well, we only have 2, so it's not that hard. Just pick a point anywhere on the blue line. So it says, okay, I want you to look at the blue. Pick a point somewhere on the red. Doesn't really matter. So now it's going to use the blue and the red. And then the guess. I like to get the guess kind of close to the intersection point. Because if we had a parabola, like a U shape, it may cross twice. And we have to tell it which one we want. So if you take a guess closer to your intersection point, it'll give you that one. In this case, there's only one. All right, so you don't have to worry about it picking up another intersection. And then we hit enter, and it tells us exactly what we already knew algebraically. Cost, it's 175 miles for $50.
Wait, how did you enter that in so it stay on one line and just go on to the other? Like, how do you make it so it tracks straight to the intersection?
How do we do? So you got both those lines in there?
How do you like make it so it's on both lines?
Oh, how it's on both? So you go second calc, intersect, and then let me just move down a little so you can see it. So right now I'm on the blue one, and I hit enter, and then it just jumped up to the red one.
Okay.
Yeah, it just did it automatically. Enter, and the guess I could just hit enter. It'll find it. Okay, the only time you got to worry about the guess is if you have like a U shape or something that intersects multiple times, then you got to be a little more careful. Any question on how we did that? So 2 different ways you can kind of go about it, graphically or algebraically. All right, so in our book, a lot of times they're going to talk about the viewing rectangle. That's that window. Okay. So for the problem we just did, this is our viewing window. X is 0 to 200, Y was 0 to 70. Okay, and when you have a graph you want to make sure that your viewing window shows all the important features of that graph. So let me show you, this part you can just watch me do this. Let's do, okay, what I'm creating right now, and you might already know this if you foiled or distributed all that out, it's a third degree polynomial, and I'm making roots at -1, 2, and 4. So it's going to cross the x-axis 3 times. It's going to be, well, let's see what kind of shape it is. That's actually a good window for that picture. It shows everything I wanted to show. I was trying to make something go off the screen. So let me zoom in. Okay, that's not a good window. All right. As we start to learn about these kinds of functions, we're going to learn how many times a graph can turn. So if I were to distribute this out, I know it's a cubic function. So I'm looking for it to turn up to 2 times. Okay, it can turn one less than its degree. Right? Just like a parabola, it's a degree 2, it can turn 1 time. Okay? Degree 3 can turn 2 times. When I look at this picture, I'm kind of seeing something that it could look like a parabola. I'm not sure. There's probably some hidden behavior off the screen. This is not a complete graph. In this case, a much better window is just the standard window, -10 to 10, -10 to 10. I can see the first turn, second turn, and I know it's never going to turn again because of algebra. This is just going to keep heading down forever, and that'll go up forever. Right, so we have to start to learn the kind of characteristics you should be looking for, so that way you know what's off the screen and what, even if it's off the screen, maybe it doesn't matter because it's never going to turn again. All right. So in any homework problem where it says to graph, you can always use a graphing calculator. If it says to sketch, that's where they're usually asking you to just try to sketch something by hand. And if they ask you to graph and tell what the window is, just write down your x-min, x-max, y-min, and y-max. Okay, let's try this one. Y equals x squared plus 10. Okay, before I graph it, anybody know what it's going to look like? I think someone might have just said it. Yeah, it's a parabola. It's a degree 2 polynomial. A degree 2 can turn 1 time. So you could either have a U shape like this or like that. It has to be one of those shapes. Okay, and actually by looking at the coefficient of x squared, we can tell whether it opens up or it opens down. In this case, it's a positive in front of x squared, and eventually we'll learn what that means. But for now, let's just graph it. If you're not sure where to start with your window, a good place is always Zoom 6. Just try the standard window and see how that works. All right, now I don't see anything on the screen, so one of 2 things could be happening. Either one, I typed it in wrong. Okay, but it's pretty basic. I'm pretty sure I typed everything in right. So anybody else think they can tell me what's going on here? Well, Dominic, what do you think? What do you think's happening here? What might be a reason why I can't see that picture? Think about that graph I drew that had all the turns in it. Why couldn't I see all those turns earlier? Help him out, Ashley?
The window's too small.
Window's too small. It's off the screen. Okay, so this time it's off the screen. Well, we got to find where it is. So one thing sometimes I do is I pick a value for x, like 0, plug it in, and then kind of figure out where I'm at. Maddie, if I plug in 0 for x, what do I get for y? 10. So in this case, I know that when x is 0, I'm all the way up at 10. Well, my window only goes to 10, so it's off the screen. So what I would do is try setting the y max a little higher. Now it's a squared function. Numbers that are squared grow pretty quickly. So by the time x is at 6, y is already at 46. Right? So I might set my y max maybe up at 75. And that's a pretty good picture. It's a parabola, and the most important thing to see in a parabola is make sure you can see that turn. Okay? This is called the minimum. And on the calculator, there is a way to find the minimum. Okay, I can show you that. Go to second calc and pick the third option down. Now, minimum is a little different. You're not using two graphs at the same time. You're just using one graph. Okay? And it should say left bound. Okay? Left bound means basically pick somewhere that you know is to the left of the minimum. Okay? So move your cursor over to the left a little bit. Hit enter. Okay? So basically what we're doing is we're marking where we think the minimum is, and the calculator is going to try to find it from there. Okay, right bound. We can go to the right. And the calculator draws in these dotted lines, and it's going to look for the minimum in between there. The guess, it's not really important in this case. Sometimes you'll have a function that could have multiple minimums. In this case, we only have one. So don't worry about the guess. Just hit enter. And it says y is 10. So that's the minimum y value. And does anybody know what this is? It's 6.8866 e to the negative 7th. Yeah.
E would mean times 10 to the negative 7th.
Yeah, it's like scientific notation. So what this is basically saying is it's 0.000006. Well, that really should say 0, because we know when we plug in 0, 0 squared is 0, 0 plus 10, that's when you get 10. Okay? The calculator can't figure that out, okay, just because of the way it's programmed. But keep in mind, if you see something that's 0.000000 and then a 6, it probably is 0. Any questions on that? Okay. Anybody stuck on the calculator? Doing okay? All right. So now you know how to find a minimum. You probably know how to find a maximum too. It's pretty much the same thing. And you know how to do an intersect. Okay, so that curve, I think somebody said it earlier. Maybe Jacob. It's a parabola. And this is the general form of a parabola. ax squared plus bx plus c. Where a, b, and c are real numbers. Plug in any real number you want for a, b, and c. As we start to learn more about functions, we'll kind of learn what happens when you change one of these numbers. Like we did y equals x squared plus 10. So basically what I graphed was that. I graphed something very simple, x squared plus c. There was no middle term, and there was no number in front of x squared. Well, if you put those numbers in, you can change some characteristics of the parabola. Maybe we can make it narrower or wider, and then maybe we can move it on the screen to different spots. Okay, but for now, I just want you to know that's the general form of a parabola or quadratic equation. You've probably seen that as well. Okay, let's find a complete graph for this. Okay, but before I even type it in, what kind of function is that? What does that symbol mean? It's a square root. Okay, if we're dealing with real numbers, what do we want to be careful about what is under the square root, or what we call the radicand? What do we have to be careful about there? Yeah.
It doesn't go into a negative.
Right, we don't want what's under that root to come out negative. Okay, because if you try to take the square root of a negative, then we're getting into imaginaries. Okay, we're not there yet. So can anybody give me a restriction on what x could be? Like it could be 0. That'd be fine. You know, it could be 3. That's fine. What's the lowest value x could be? Yeah.
X should not be lower than negative 20.
Right. X can't go any lower than negative 20. Could it be negative 20 exactly?
Yes.
Yeah.
Yes. You can take the square root of 0. So in this case, that gives us a restriction on our window. X has to be greater than or equal to negative 20. Try plugging in negative 21 and see what happens. Negative 21 plus 20, it's negative 1. Square root of negative 1 is imaginary. And we're not doing that yet. Right, so now let's type that in. We already have an idea of what we're going to set our window at. Square root of x. I probably should have cleared it first, because sometimes it's kind of a pain to do it after. It's fine. And now square root functions, they don't grow very quickly. Even if I let x go all the way to 80, 80 plus 20 is 100. And what's the square root of 100? 10. So even when x is at 80, way far out, y is only going to be at 10. So you don't really need to set your y max very high. I would say keep it at 10. And when we take the square root of a number, this symbol means principal square root, so we're not looking at the negative. Hopefully you guys remember every number does have 2 square roots. Like the square root of 4 is 2 and negative 2. But there's no minus sign in front of that, so we're just looking at the positive answer. So we don't need to go below 0 on the y-axis. But we do need to adjust our x's. We know we can go as low as negative 20. And let's go as high as 80. Just because when you plug in 80, it gives you a nice answer. 80 plus 20 and the square root of 100. Okay, so that's what your square root function looks like. And if you wanted to kind of get an even broader view of it, let me show you how to zoom out. You can press zoom, go to the third option down, and then it puts a cursor on the screen. Just hit enter, and it's going to zoom out. Okay, so now you're looking at it a little further away. Notice it doesn't go past negative 20 because it can't. Can't go negative. So it starts right there, and it's just going to keep going to the right forever. Kind of going up very, very slowly. Very, very slowly. Any question on that picture? So for the answer to this problem, find a complete graph. Well, we've done it. The only thing we could write down is our window. Okay? We could just copy that down. If I can put it in there. All right, the other thing you can do is sometimes you're looking at a function and you want to plug in values for x quickly and find out what y would be. Okay, just like I plugged in 80. So now I want everyone to press second and then the button window. Okay, above it it says table set. So press second and then window. Okay, if yours isn't already set up this way, put your independent variable on ask. Keep the dependent variable on auto. Don't worry about anything else. Everybody got that? All right, now press second and then graph. Okay. What this is going to do is it's going to bring us to the table. Now, if you've already got stuff in your table, if you just press delete, it'll clear it out. But what this table allows me to do is pick a value for x, plug it in, and it'll tell me what y is. So for example, if I plug in 80, what should y come out to? 10. It does. So it's just a quick way to plug in values for x and get the answer for y. If you plug in 61, yep, that would give me 61 plus 20 is 81. Square root of 81, 9. Okay, so that's a nice answer. And you could do stuff in between too. If you plug in 25, it's the square root of 45. Right, so this is kind of handy sometimes if you just want to test a few points. Maybe if you're trying to draw a picture, you want to get some coordinates to make your picture. But it is kind of important you set your table setup the way I did. Otherwise, if you put it on auto, let's see, start it at 0. Let's see. What it's going to do is it's automatically going to fill in the table, and it will not allow me to type anything in. All right. So if I wanted to know what happens when I plug in 80 for x, I'd have to scroll down till I get to 80. That would take a lot longer. All right. Yeah.
There's no y1. It's just x on this one.
There's no y1.
Yeah.
And do you have an equation typed in there?
No.
Yeah. Let me make sure you have your equation typed in. And if I change this equation, it'll automatically update the table. This table is recalculated based on whatever you type in under your y1. And you could type in another one if you wanted. And by typing 2 in, then you could compare values, two graphs at the same time. You just have to remember, well, actually you can highlight it. If you forget what you typed in for y1, you don't have to go back to the main screen. Just highlight y1 or highlight y2 and you can see the function you typed in. Right, graphing data points. We don't really graph a lot of data points, but you could use the calculator to make like a scatter plot, just plot some points. I'll show you how you can do it. But this part, again, not as important as the other stuff I've shown you. All right, let's say you want to type in these coordinates. Okay, just graph them. What you can do is press the button that says Stat. You're right below Delete. And the first option you see is Edit. Just pick that first option. Now, you might already have something on the screen. If you do, just press Delete. It'll get rid of anything that's there. Okay, and these two lists are basically where we type in our x's and y's. All the x's go in list L1. All the y's go in list L2. Right, so let's try to type in some of these. Since it's going to go down L1 every time I hit enter, I'm going to type all my x's in first. Then I'll go back and type in all my y's. And what else do I have? 2, 3. So it's just -3 to +3 going by integers. Okay. And then type in your y values. To get to the next column over, just press your right arrow or left arrow. And then the last two are 2 and 18. So you can kind of see some symmetry here. If you look at my values. So that might give you an idea of what it's going to look like when you sketch it. 2 and 18. All right, first thing I'm going to do, if I have anything else already typed into y equals, I'm going to clear it out so I'm not graphing multiple things at the same time. So I'm going to get rid of all that other stuff. I could leave it, it's just going to look confusing. And the next thing I have to do is I have to turn one of the plots on, okay? Because we're making a scatter plot. So what you can do is, if you're in this screen, just press up till you highlight one of the plots. Hit enter. And now it should be highlighted in black. Okay, it should be turned on. Anybody have trouble turning it on? And the last thing we have to do anytime we're going to view something on the screen is what? What do we have to always check? Yeah?
Window?
Yeah, we always got to check the window. Right? This time it looks like my y's go from, I'd probably go negative 20 to 20 on the y's. That'll grab everything. And, yeah, maybe negative 5 to 5 on the x's. If we don't, we're going to go off the screen. This would be an awful window. Okay, that wouldn't be good. So we said negative 5 to 5 on the x's, and negative 20 to 20 on the y's. And if you hit graph, you can see all the points we just graphed. Now there's also a way I can have the calculator fit a curve that goes through those points. But that's getting into more statistics. Okay, I'll show you that. This part I just want you to watch. Okay, don't write any of this down. Just watch this part. This is handy if, like, you're doing an experiment and you have a bunch of data and you want to see if you can find an equation that models your data. Well, the calculator can do it automatically. And I'm just going to show you how. So it says the equation is, it's a cubic, which makes sense because it turns twice. And it's x cubed minus 3x. Let me graph that and show you what happens. That's the exact equation that models those points. Sometimes it's not always perfect, depending on if you're really gathering data in a science class. Your line might not be perfect, but this one is perfect because I made it that way. Right, but don't worry about that part. I'm just showing you that it can do it. Okay, these are all the steps we went through to type the points in. Honestly, I think it's more confusing to write it all down, but if you are more visual, you can write the steps down. We went into stat, typed our x's and y's into L1 and L2. And then after that, we went into y equals, and we had to turn the plot on. Now, we might want to remember to turn it off, otherwise it's going to be there on everything we graph. Okay, so usually once I'm done with the stat plot, I'll go back up to it, click it, turn it off. Okay, and your very last step, always check your window, make sure all your data points are going to fit on the screen. Another good use for the stat plot is for finding patterns. So towards the end of the year, when we get into like sequences and series, we can type those points in, just like we did, and the calculator can basically try to find a pattern in a list of numbers for us, doing exactly what I just showed you. Anyone else need these steps? Okay, and if you do need them, they'll be in the video online tonight too. All right, this part I already did for you. It says show that this equation is a good model for the data in example 5. I just did that. If the curve looks like it goes through the points, it's a good model. Okay, here's something that's not a good model. Goes through one of the points. It's kind of close to a couple others, but it doesn't really model the behavior. So that's all you have to do to show that it's a model. Hey, so any question on that part, 1, 2? All right, so all of that in the homework, there's really not going to be anything for you to write down other than windows. There's no calculations you're really going to have to do for that. It's just practice with the calculator. Okay, and the way I'll test you on that kind of stuff is I might give you a function, give you multiple choice answers, and say which of the following is a good window for this function. So you have to know how to try them and see how to set your window. So section 1.3, we won't use the calculator as much. This gets into some terms that hopefully you already know. But different names for the x and y variable. So earlier I called the y the dependent and the x independent. Another name for that is input and output. Plug in for x, get an answer out for y. Domain and range. Okay, how many people have used those terms before? Domain and range. A lot of people, yeah. So we'll use those a lot. And then the last terms I already used with you. Okay, so a function. Does anybody remember what a function is from Algebra 1? Either the definition or you can describe visually what it would look like. Does anybody remember a test that we often use with functions? You draw something on the screen and see if it passes this test, and if it does, it's a function. Vertical line test? Anybody remember that? Vertical line test? No? All right. Well, let's start with the algebraic definition of a function. So every input has exactly one output. So for every x value, there is only one y value. Don't worry about the second thing. Your book uses some different notation. I would just go with this. It's an algebraic equation where every input has exactly one output. Okay, another name for the input is the domain. And another name for output is range. We already said that. So another way you could say the definition up above is every value in the domain has exactly one value it's paired up with in the range. So one way, sometimes we show this in Algebra 1, like students are starting out, is we draw a diagram with domain in one column, range in the other. So if I had domain, range, just pick some values in the domain, pick some values in the range. And we might do something like this. So we look at that and I'd say, is that a function? I'd say, well, does every value in the domain match up with exactly one value in the range? What do you think here? Yeah, that's a function. That's perfect. Okay. Now, if I did something like this, would that be a function? No. Because now you have a value in the domain that matches up with two values in the range. So this is like saying if you plug 5 in, you could get 6 or you could get 12. That's not a function. Okay, for every value you plug in, you get exactly one answer out. Okay, how about if I did something like this? Is that a function? Yes. If I plug in 1, guarantee I'm going to get 6. It only goes to one spot. If I plug in 2, I'll get 3. If I plug in 5, I'll get 6. It's okay to have 2 arrows going to the same number here. You just can't have another arrow coming out of here going somewhere. Okay. Okay. So unless otherwise stated, for now, the domain is always a real number. So if you're familiar with imaginaries, don't worry about those yet. For every problem we study until I say otherwise, the domain is always a real number. Okay, our book also goes over a different way, a different notation you can write a function. Does anybody know what you can write besides y? F of x. Is everyone familiar with that? Okay. We'll use that notation quite a bit. What's nice about it is if we have multiple functions on the screen at the same time and we name them with a letter, we could have f of x, g of x, h of x, and then I could say, look at function f, look at function g, look at function h. Versus if I just use y, we could put little subscripts like y1, y2, like the calculator does. But a lot of times we just name it like that. Okay, so if you see f of x and you're not comfortable with that notation, keep in mind, always just change it to a y if that seems easier for you. All right, so this one, if you want to graph it, you can. We've already graphed a square root today, so I don't think we need to graph it again. But I'd like to find the domain and range. Some people like to see it visually, and that makes it easier. So if you do want to graph it, that's fine. Just put it up real quick. And I'm going to shut my scatter plot off so we don't see that anymore. Okay, so remember your domain is all the values that you're allowed to plug in for x. Your range are all the answers that you're going to get when you plug in those values. So based on what we know about square roots and looking at that picture, what kind of values can we plug in for x? Anything that's what?
3 or greater.
Yep, you got to pick numbers that are 3 or higher. If you go below 3, you're going to get negatives. So we can say x is greater than or equal to 3. Or sometimes you might see, has anybody ever seen this notation? Anybody ever seen it written like that? What a bracket means is you can include the number. A parenthesis means you can't include it. And this is saying I can go from everything from 3, including 3, all the way up to infinity, but I can never reach infinity. So we always put a parenthesis on it. Either notation is fine. How about the range? What are the y values going to be? From what to what?
Always 0.
Yeah, the lowest value you'll ever get is 0, and it's going to very slowly keep going up. And it'll never stop going up. So your range is greater than or equal to 0. I think our book introduces this notation a little bit later. I'll just start to show it to you now a little bit. Okay, let's try this one. What shape is that going to be again when you have x squared? That's your parabola. This is a parabola, and this number at the end shifts it down 4. So in my head, I'm already thinking something that looks like this. And if I can visualize that picture, I can pretty much already figure out where my domain and range is. Start with x. Is there any number that you are not allowed to square? No. You could square anything you want. Okay, so in other words, this parabola is just going to keep going left and right forever. It's never going to stop. No, so domain is all reals. The only time you have to be careful with your domain is if you have a square root. If you have division, I wouldn't plug 2 in for x and something like that. That's a problem. Divide by 0. And that's it. As long as you, square roots and division are really the only time that you have problems with your domain. In the range here, it's going to start at -4, and it's going to go up forever. If you want to graph it, you can graph it, and you'll see that picture. That lowest value will occur if you plug in 0 for x. If you plug in anything else for x, you're going to get a number higher than -4. It takes a little practice to get used to the domain and range, but we'll practice it quite a bit. Okay, take a second, try that one on your own. It's very similar to the one we just did, except what are these bars around it called? It's absolute value. So keep in mind what that does. And this is actually a good one. We'll graph it after. But take a second and try that. So since we can plug anything we want in for x, our domain is all reals. Now y. Y are the values we're going to get out. Okay, so when you plug in any number you want for x, what kind of answers do you get for y? Or think of what kind of answers would you never get for y. Think of it either way. And these bars are going to play a part. Yeah?
Sorry.
Go ahead, yeah.
All right. It was y would equal anything greater than 0 because the absolute value makes so it's always positive no matter what comes out.
Right. You're never going to get a value that's negative here because you have absolute values around it. If you do get a negative, say you plug in 0. 0 squared is 0. 0 take away 4 is -4. But then you're going to take the absolute value and it becomes positive 4. All right. So you'll never get anything below 0. So it changes it a little bit. Let me show you what it looks like. This part, you can just watch me do it. There's x squared minus 4. When you put absolute values around something, all that it does is it takes the part of the graph that was negative and basically flips it up. So what we're going to get is a picture. It almost looks kind of like a W shape. It's going to take this negative part and flip it up. This part, watch, because I don't think you know how to type an absolute value in yet. Okay, I'm going to put insert, because I want to insert an absolute value. And I believe it's under math, number, and it's the first option. ABS stands for absolute value. Now I'm just going to have to retype it. So now I'm going to type in x squared minus 4. Sometimes it's easier just to clear it and retype it. So now when we look at it, that part that was down below the x-axis should be flipped up, exactly like that. It's like it's trying to go negative, and the second it tries to, it flips it back up. Okay. And if I look at that, if I wanted to try to figure out the domain and range just by looking at the picture, ask yourself, how far left and right does the graph go? Well, it's going to keep going left and right forever. Zoom out if you want to see it zoomed out a little bit. It's going left and right slowly, but it is. And it's going to go up forever. It doesn't go down. It only goes up. That's why our range is all values greater than or equal to 0. Right. Sometimes when we have f of x notation, we use it to plug in a number and evaluate. So if I give you a function and ask you to find, say, f of -2, f of 3, or f of a. Basically, all that means is take this number, plug it in for x, and simplify. Take that number, plug it in for x. Or take that letter, plug it in. Okay, that's all that notation means. Take the number, plug it in for the letter. Okay, let's start with -2. Okay, how about Bill? What do you get when you plug in -2 squared plus 1? Good. You get -2 squared is 4 plus 1 gives me 5. That's it. Okay, if I plug in 3. Okay, how about Cameron? What do I get if I plug in 3? Perfect. 3 squared is 9 plus 1 is 10. Getting a little bit more tricky. What if I plug in a? You just a squared plus 1. There's nothing I can do. And the last one I wanted to plug in is x minus 3. Is that all I can do with that, or is there something I could do there?
Distribute the square.
And how would you distribute it? What do you mean?
Like you would give it to the x and you give it to the -3.
So like x squared minus 9 or x squared plus 9?
The x squared plus 9.
Okay, so that's part of it. Those are 2 parts. There's something we're missing though. What happens here? Yeah, Dominic?
You could use the FOIL method because it'd be x minus 3 times x minus.
Right. Remember, this really means x minus 3 times x minus 3, which then, as Dominic said, you can FOIL. All right? So you do get the x squared. I like that part. You do get the 9. There's just something in the middle you're going to get, minus 3x minus 3x. So you get x squared minus 6x plus 9 with a plus 1. So why don't we just make it plus 10? Right, so you can plug numbers into a function. You can plug letters. You can even plug in an expression like that and just do it out. Okay, any questions on that? All right, and last thing. This part I already mentioned to you, so you kind of already know it. Not everything you can draw is a function. For example, if I take this equation, y squared equals x, take the square root of each side to solve it, get y by itself. When I take a square root, I have to make sure I include the positive and the negative. Let's see what happens if I graph that. Okay, let's see what it looks like. I'm going to have to graph it as 2 parts. I can't graph it all together. I want to see if you can tell me why it's not a function. So the top one is the positive square root, the bottom one is the negative. Why is that not a function? Yeah.
Because like there can be many values that match up like multiple times.
Yeah.
Like if you have an x value, then it can go up to the blue line or down to the blue line.
Right. Exactly. It's perfect. If you pick an x value, it could either be up here, it could be down here. So for every x value, there's 2 y values. That's not a function. Okay. Also, if I were to draw a vertical line here, how many times would a vertical line hit this graph? Yeah, it hit it twice. Okay. If a vertical line hits any graph more than once, it's not a function. Okay. And that's the vertical line test. Okay, so the vertical line test states if you draw a vertical line anywhere and it hits your graph more than once, you do not have a function. How about this? It's like a sine wave or a cosine wave. Would that be a function? Yeah. Vertical line is fine. No matter where I put a vertical line, it's only going to hit it once. Horizontal line is going to hit it more than once, but that's different. How about a circle? Would a circle be a function? No. Because if you drew a circle, vertical line hits it more than once. How about a parabola? Yep. Vertical line would only hit a parabola one time. So this is not a function. This is a function. And this is a function. Any questions on that? All right, so I know it's kind of a lot of stuff. A lot of it was probably review, maybe not the calculator stuff. So as we get into the material more, we won't be doing a section and a half. We'll probably be sticking to a section or even sometimes half a section a day. All right, so the first part of the homework, it's all graphing calculator, so there's not really much to write down. The second part, there is some more to write down. So it's on, first part's page 20. It says 1 to 10, 18, 21, 29, 32, and 38. And the part we just covered on functions, that's page 30. 1 to 8, 11, 13, 16 to 19, and 24. The video should be up by this afternoon if you need to double check anything from class today.